Is that a real window behind you?
A real window with a
Ah.
real poster behind the window. No, it's nice. That is Big Ben. Awesome.
I've used a special mug today. It's a mug that I designed.
Okay, nice.
The Freedom Project, which is what I did for Wales and West jointly with Western Power, was a heat
Okay.
gas boiler optimization heating system project. But as a giveaway, we had hybrid mugs, so where you could have both coffee and tea
Ah, that's
in the
cool.
same mug.
Hi guys, welcome to Heat Geek podcast, also available on YouTube. Today we're going to talk about hydrogen and hybrids maybe, and heat pumps. And I'm joined by a very esteemed gentleman, the CEO of IGEM. Do you want to introduce yourself?
Yeah. I'm Oliver Lancaster, Chief Executive of IGEM. I've been there for just over a year, and my background isn't necessarily with heating or energy. I come from a contaminated land background, really, cleaning up the history of the energy industry and the leftovers of when it was very dirty, the gas production from coal, particularly. And then joined the gas network, looking after land assets to get them turned around and cleaned up on any of the contaminated land liabilities, and then started to work in the future of energy space.
Okay.
Got involved a lot with biomethane and hybrid heating systems and optimizing the energy system and trying to design and optimize the energy system. And then I then landed in IGEM, the Institution of Gas Engineers and Managers, which is the professional engineering institution for the gas sector.
Yeah, so I recognise IGEM because they produce the documents I used to refer to when I did commercial calculations.
Right.
That's right, isn't it? And then I think, so you're also a body for the energy companies to become part of or something. Could you just tell us a little bit more about that?
So we have individual members, so I'm an individual member. I was before I joined IGEM. You can be a non-engineering or engineering member, and you are developed in your knowledge and career and helped along the path with training opportunities, things like that. But particularly for engineers, there's the opportunity to progress through the engineering grades through engineering technician, which I think we both are an engineering technician.
Yeah.
And then through to incorporated engineer, chartered engineer, and so we hold the hands of individuals in the gas sector, not just in Britain but overseas as well. Quite a few across in the Far East as well. We're starting to have a lot of interest in India, but company members as well. Yeah, we have a lot of the supply chain for the gas sector, but it's typically kind of the gas networks are in there, but a lot of the organizations who are part of the supply chain from when gas enters the shore to the meter, but increasingly we've got like housing associations and some installers joining as well, so it's not just upstream of the meter, and we're getting interest from further away from the shoreline as well. So
okay, that's really interesting. So international. So okay, I'm going to get straight into the meat to make this like as exciting as possible and go to the challenging questions.
okay.
You're a hydrogen fan? Question mark for heating. I mean, hydrogen for home heating fan? Yes, or
I am definitely in this space that hydrogen has a role in domestic heating and across different demand sectors, but I'm also in the camp that heat pumps and heat networks, heat pumps, that's ground source, air source, air to air, air to water, whatever. There's a role for lots of things, and energy efficiency, obviously. But yes, I believe that hydrogen has a role to play.
okay, so I think that's quite a common opinion. Where do you think the boundaries are of, okay, we're not we're not now going to be using hydrogen for these, heat pumps for these homes. We'll use hydrogen for those homes. Which homes can't be done with heat pumps?
Well, I saw the headline from the electrification heat project, which is, I'm really glad that happened, which said heat pumps can be used in all homes, and I can't argue with that. I'm pretty sure it can be. It depends on how much we've got to throw at it for it to be efficient and to be suitable for that home. So there's there's an element of the type of housing that might naturally lead towards a particular solution, or if a home is near a long-term source of waste heat, heat network or something. But I think it's important there is an element of choice in there for customers as well, for what to have.
Yeah, and I definitely can't disagree with that. I'd say, for a lot of big leaky houses, and I'd say more than flow temperature, especially now the heat pumps are running at high temperatures, it's power. So big leaky properties that you need a lot of power in get very expensive when you need 30, 40, 50, 60, 70 kilowatts. However, that is, it's 2% of homes or something, isn't it? Having said that, if you were going to heat, well, if you don't use a heat pump, you'll use natural gas, right? That's probably fine, except for the carbon, obviously. Hydrogen, that would be pretty expensive to heat that building with hydrogen, right? Well, we think, we don't know.
In fact, we don't know exactly what the price of hydrogen will be in the future at the moment. It's not particularly cheap to produce right now. There are obviously different types of hydrogen. And I know there's excitement around the rainbow of colours and different ones you can have, and it's not just black, grey, brown, blue, and green. There's other colours, pink and yellow and white.
I've seen.
Gold, but whatever happens, wherever it's coming from, it needs to be low carbon. It needs to be compliant with the net zero pathway, because I think what everyone can agree on, whatever the solution of heating is, we need to reduce emissions as quickly as possible to bring cumulative emissions down, to reduce the impact of climate change. And so that's a great place to start.
Great. Yeah, definitely.
But the price, though, I've been involved in some very detailed modelling on this in the past. So hourly modelling over a year using real supply demand data and changing for different scenarios, different supply capacities, different electricity generation, different hydrogen, gas supply scenarios, different energy efficiency improvements in homes and retrofits, different amounts of storage capacity, batteries in salt caverns or whatever, and it all has an impact upon the price that the customer pays on their bill for their energy, their heat, their power, their transport. But there are ambitions, and the UK is part of a mission, an international mission with the USA, Chile, EU, Australia. I think they're the leads, and then there are others involved as well. That's looking to bring hydrogen down to I think roughly equates to 4.5 pence a kilowatt hour for green hydrogen by 2030 on a customer's bill, which is, it's ambitious, but we need to be
That's very ambitious. Did you, obviously you looked much more than me, but in my very, very small, quick, light investigation into the potential price of hydrogen, and how I did it was I worked out how much the electricity is going to cost at source, and then minus the inefficiency of turning it into hydrogen, minus the efficiency of burning it in the hydrogen boiler type thing. For me, it worked out better to turn excess green electricity into hydrogen, so use hydrogen, then turn it back into electricity and run it through a heat pump, because you end up with more energy again rather than ever decreasing energy. Did you find that, or did you do that some?
So I think the system as a whole needs to be designed to have the right capacities across it. And that involves to get down into some detail of, so to fully electrify,
Yeah.
The drawing I think you might be referring to on the efficiency through from the turbine blade
Yes.
to the emitter,
Yeah.
and that going through the path of
Mm.
the electron going down through wires to heat pumps into people's homes to heat their home, and
Yeah.
likewise turning that energy into hydrogen and then sending it down to people's homes and using it in boilers. Big
Yeah.
difference in efficiency.
Yeah.
But what it doesn't reveal is the total system cost of delivering that wonderful efficiency.
Yeah.
And a lot of that hangs on the utilization of assets and how much the assets to enable something to work are going to be used. And quite often, everyone who wants to invest in something makes the assumption it's always going to be used, or they have to be very careful about what exact technology they're going to invest in.
Yes.
Because if it's going to be used hardly ever, then it needs to be this technology. If it's going to be used a bit, it's this. If it's going to be used a lot, it should be this.
Yeah.
What's going to end up being lowest cost on the customer's bill. And so what matters is how much needs investing in, how much it's going to be used. Try not to overbuild capacity across a system that costs a lot on the customer's bill.
Yeah.
So I'm in agreement it needs to be affordable, absolutely, in a transition that brings emissions down.
I just can't. I still can't see. Right. So what I do know is that we have a 270 terawatts heating demand in the UK. If we use hydrogen to fulfill that, we're going to be needing to use around about 400 terawatt hours of green electricity. Ideally, if we don't use, I say green electricity, obviously I mean solar, hydro, etc., to create the hydrogen to then send to the gas boilers. I mean, green hydrogen is the only route, right? Green hydrogen being created from green electricity. Is there other stuff being developed that could be, because blue, just so we're on the same understanding, I think blue is the one that recaptures the carbon, right? That's right, isn't it? Haven't they've only proven that that's kind of similar to just burning natural gas directly, or only a small amount of reduction, or even if it's half, it's not enough of the saving.
So I think what is agreeable largely is that blue hydrogen is likely to be a substantial reduction, but it's certainly not ending it. But there is a need for blue hydrogen for the scale and speed of decarbonisation, particularly of industry, soon, and green to go with it, as fast and far as possible. Being aware that you need to have the supply of green electrons to deliver that green hydrogen. I'm happy to get onto the marginal generation for hydrogen production and heat pumps. It doesn't matter. It's two new transferred loads or whatever. So blue's got definitely a role to play. I don't know for how long, but for the time being, no matter what capacity is being put in the energy system, I don't think we really need to be too concerned about how much capacity we're putting in at the moment and what the end capacity should be of different things. I think we can get on with it.
I mean, we're kind of mixing things here though as well, because like obviously my focus is hydrogen heating. Will that be a thing? So hydrogen heating, we need like 400 terawatts for 370 terawatts of electricity for. We need 400 terawatts of electricity, of green electricity for transport. We need 400 terawatts of electricity for industry, and we need another 330 terawatt hours for the electrics in people's homes. So ovens, whatever, probably electric cars might bump that to about 350, 370. So we've got like 1,500 terawatt hours that we require. However, in 2020, we produced 120 terawatt hours. So if we're going to divert hydrogen somewhere, we're probably going to start at those other things and then probably home heating last.
It's difficult to separate out, I would say, the different demand sectors. because they're all around each other. Take, for example, somewhere I'm more familiar with, South Wales. That's where I live. I'm from Greater Manchester originally, but I lived here for a while.
Yeah.
South Wales has got quite an industrial cluster. It's quite dispersed. Some of that can definitely be electrified. Some of it definitely needs to decarbonize molecules that are put into their system, but some of them actually need natural gas for the long term, because it's an ingredient chemically to what they do, and that's an extra challenge. How do you make sure that they continue to get methane supply? But around that, you've got power generation as well. You've got some big significant gas turbines around in South Wales. You've got also gas engines as well, which do the local peaking flexible generation. And they are located, oh, sorry, that's a compressor on my beer pump. Sorry, it will go off.
I can hear it again. Yeah.
It'll go off in a second. But yeah, compression. There we are. Happy days. There we are. It's done.
Did you just have one this morning before you came on?
No. That one's empty actually. So that one's got a little bit left in it. But there's a risk a compressor might go off on either of them.
That's all right.
So there are gas engines that do the local generation. The distributed generation connected between gas and electricity distribution networks, and they are located all over the place amongst homes and businesses in towns and villages and things like that. So they do a lot of hard work supplying electricity when it's needed, when they get the signal to come on. And we need that kind of asset in the future running on hydrogen, and local pricing, local energy, local designs are going to need local solutions, and having that local backup that runs on a low load factor for when it's not windy or whatever, that they're pretty helpful. But you've also got industry that's not clustered, a heck of a lot of it all over the place. So it's not a case of the earliest thing you can do is for the industry that is clustered. Yeah. But you don't want to lose that tax, those jobs and revenues overseas because everyone else can't move first. But there is a natural rollout kind of way you would do this from where you get initial large production, which is around industrial clusters. Yeah.
Okay, so going back to heating, hybrids. You're a fan of hybrids?
I am.
So I was, and I was up until about 2 years ago, and now I'm much less so. But I'll let you say your bit about hybrid first. Why you think they're needed?
I'm really keen to hear why you've fallen out of love with them. So I started my it wasn't a love affair with hybrids. It was just a project that I was given to lead for the gas sector. So it was when I was.
And sorry, just for listeners, hybrids means a heat pump and a gas boiler put together, and you use either one when it's cheaper, or one when you need more temperature, or one when you need more power, depending on
or
to minimise carbon.
Or in response to whatever upstream system needs there are. Exactly. So quite a good flexibility tool. Yeah. So that this is a hybrid between an air to water air source heat pump and a gas boiler, and there were other hybrids available, other hybrids on offer. You could get a hybrid at the time, but not really from many organizations. But I worked with an opposite number in an electricity network on delivering 75 of these installed in Bridgend, in the Bridgend County area, to test these in combination of social and private homes. I know how easy are they to get in, how accepted are they, do they deliver what the customer wants, is behavior wise it relatively easy to adopt in comparison to what they've been used to, trying different sizes of heat pumps, trying different manufacturers of boilers. We did get one system boiler with a hot water tank, but the rest were combi boilers. But we tested loads of controls on them, and they offer a significant value, in that, yeah, in summary, you more or less said some of it before. You can use them when electricity is cheap, when the wind's blowing, the sun's shining,
Yeah.
and then when electricity is expensive, which I think it will be much more peaky and troughy in the future than just waving around. But when you get those peak prices, then you can go over to using the gas boiler, or the boiler that uses whatever molecule it might receive in the future.
Yeah.
But one of the last things I was doing with hybrids, before I started at IGEM, was having a whole system carbon backstop control to it. So that's where you have a minimum COP threshold on the heat pump, below which, on a whole system perspective and the flexible generation being used to put into the system, you'd be better off using natural gas in the boiler rather than natural gas or coal, or a mixture of the two at the top end. Go on.
What year was that you were doing that?
So the installations were 2017 to 18. The report was late 18, and the CCC produced a report at the time, Hydrogen in a Low Carbon Economy, and about the same time was we released the Freedom Project report, and that talked about the exciting potential of having hybrid systems with hydrogen.
Well, so the issue I have there is, if we take it back to natural gas, is that now that electricity is the same carbon intensity as gas, pretty much, the COP would have to be below zero to be more like. Obviously, there's the cost thing, which is one thing, but if we're looking at carbon, it'd have to be a COP of below 1.
So yeah, I totally understand. So this is where we can get into and it's an uncomfortable debate, and there'll be a few people watching this who will get very angry at me saying this.
Go for it then.
What about my PlayStation? What about my toaster? It happens. But what's helpful is that the marginal generation debate around the transfer of demand from boilers to heat pumps and flexible generation be responsible for feeding them is now helpfully in the same space as electrolyzers using electricity, which is an extra demand on the system, and that's using marginal generation. So I think it's probably more helpful these days that we're in a compromising situation. If you think there are warring sides, I hope there isn't. I hope we can be in a collaborative way forward and get stuff done quicker. But this is where so cast your mind back to I don't know, beginning of 2020, late 2019 or something. You could argue that all the marginal generation's gas, or you can argue that it's gas.
Just for the listeners, can you explain what you meant by marginal generation?
So yeah, back then particularly, you never had a time when all low carbon sources were able to meet all of our demand. And so there's a bit of nuclear, and then you've got some renewables going up and down, and then filling the gaps are these flexible sources, which used to be before 1990 pretty much all coal, and then it became a combination of gas and coal, and it's largely all gas now. A little bit of coal, but a few years ago that flexible generation mix that was filling that gap was a mixture of coal, gas combined cycle turbines, maybe some open cycle turbines, different turbines, and gas engines. And collectively from a mix of those, you could get a carbon intensity of those sources. And you'd need a COP. If a bit of coal was in the mix, you need a COP of something like 2.9, something like that, to over 2.9 to overcome that upstream emission. And below 2.9, then just using natural gas in the boiler would be total system wise. If coal wasn't in the mix, it'd be something like 2.4. it was just gas sources. So that was the total
At the
system
time.
carbon
Yeah.
backstop control that was
Yes,
being
yes, yes.
like, yeah,
Which was ever moving, like you said, depending on, yeah, cool.
yeah,
Yeah, exactly. So, this is the crux of the issue, isn't it? That, or one of the issues is that if we did go, not for the 99% or 98, 99% of houses, we did go heat pumps, is the grid going to, the electricity grid going to cope? I think two things. Oh, we'll come back to hybrids as well, because it's kind of feeds into that anyway. The national grid thinks so, based on time of use tariffs and how heat pump SCOPs are increasing. And I can't see why not. If it didn't, I believe hydrogen is a good option, i.e., store that electricity as hydrogen, then turn it back into electricity to power heat pumps. I'm still not there with a
yeah.
hydrogen boiler, and I don't think I'm ever going to be. And bear in mind, I've come from being pro hydrogen boiler. We were the UK's largest hydrogen boiler installer. To being not, well, I would say anti hydrogen boiler until I get the logic. And I'm not like, I'm definitely not tribalistic. I love debate and I love my mind being changed. Like, I find it exciting, healthy. Lots of people learning the thing. That's why I kind of wanted you on. But I can't see it being there. And this is kind of why I've moved as well. Part of the reason I've changed my mind on hybrids. Hybrids were very popular, and certainly popular with me a couple of years ago, with, oh, that's a bit of an iffy house, whack a hybrid in there. Not too sure what to do there. Or some companies just go like passive systems. Not too sure if you're aware of those.
Oh
They
yeah,
just
yeah.
hybrid every single house. So two reasons you'd hybrid a house are power and flow temperature requirements. Since a couple of years ago, with the advent of R290 heat pumps and mainly actually upskilling of heating engineers, thanks to courses like our own, SCOPs aren't what they used to be. We're getting a lot more power out of heat pumps and flow temperatures. Like with R290, the SCOPs continue at the higher flow temperatures. At the low temperatures, all the refrigerants kind of get the same sort of efficiency. At the higher temperatures where the issues were, that's kind of been resolved now. What sort of SCOPs were you getting on that project you were doing of the heat pumps? Do you know? They would be better, I suppose, because when the worst end, the gas boiler would kick in anyway. So
well, I tend to not want to talk about SCOP but COP, and that's
okay.
because that's a seasonal average, whereas
okay.
what matters is the kind of hour by hour in the energy system.
So there's two reasons why we do this. So the reason we talk about SCOP is for the consumer to know how much they're going to pay over the year. The reason we talk about COP, which is more important with our conversation, is because that's how much the grid's going to struggle in the peak of winter, which is the main sort of issue. Is that what you're saying, right?
So it's how the whole system responds and uses hybrids on an hourly basis, and those peak periods in winter.
I'm with you.
And having the system designed to cope with, say, all the homes being on heat pumps, and if it was struggling winter day, fortnight, month period, or whatever, of something really difficult conditions, then what's the system behind it going to have to be? It's definitely helpful in conversation, and at the moment with and I don't mean right now at the moment with energy prices because of the price of energy, but energy prices because of the system that we have. It's helpful to still talk about.
No, definitely. What would you expect on like a 0 degree and -1 day COP to be with a heat pump? Because I think my answer will be different to yours.
You're going to tell me it's going to be very high, and I'd like.
Very high to me is 5. So
5.
Actually, 6 is very high to me. But that's -3. I don't think you can.
In the Freedom Project, we're down to I think -7. It was during Beast from the East, actually.
Right. Okay.
So that was quite a helpful test during the project. -7. And you're testing them out because this is a while ago and I don't know, but I suspect they're around about 2, something like that, around that temperature.
Yeah,
But
I'd
even
say
then,
two
but
and a
even
half is, yeah.
and they were very, we had really good installers, by the way.
Everyone thinks they're good installers. That's the problem.
Uh, we more or less had kind of lecturer level installers. I'd say like you're a lecturer level installer.
I would say people who lecture can't install. The best
Ah,
people
all
installing are
right,
people
okay.
that install. I don't think
Workshop.
I'm there either. I don't think I'm the better. Like I haven't touched a tool for 4 years. I think I'm behind most installers
Oh
now. Like,
well, we can all learn, can't we? We can all learn and
exactly.
improve. But I mean, so not lecture then,
You
workshop.
know what they
That,
say? Yeah,
yeah,
those who can't teach.
yeah,
That's why
yeah,
I'm teaching.
yeah. um, so they were very well installed. But actually,
Yeah.
there was one particular home I remember where the boiler was going full whack, but actually that couldn't meet the demand of the home itself because the home was so leaky, poorly insulated, drafty old barn kind of thing.
That needs doing anyway, doesn't it? I mean, a lot of this comes down to is the issue the technology or is the issue? I mean, I think the government just need to throw money at insulation. And I mean, I'm not going myself to the road, but I think we need more. If the issue is money, not the technology, just get the money. Like, the way we funded all the wars and we bailed UK, the banks out, and we funded Brexit, and we still are paying for that. All that money. Well, we want about what 5% of that, maybe 3% of that, and we could go and insulate all homes and put heat pumps in everywhere.
Yeah, no, I agree. We should be funding a shed load of retrofit insulation to lower the energy demand of buildings for heat. Absolutely.
Yeah.
I can be controversial, if that's all right.
You'd be as controversial as you can be. That's what gets us more viewers.
No, so often we talk about we as a sector talk about fabric first, energy efficiency first.
Yes.
It can be technology first.
You're not controversial with me here.
No. It can be technology first, and you can do it a bit at a time. You don't have to go and
yes,
as long as you do it in a whole house way. Because if you don't do it in a whole house way, you can lock out further retrofits in the future. But I think what might be controversial is not throwing it at a home, whatever the cost, because there is an economic kind of ceiling of demand reduction in buildings from energy efficiency before you then at which point then you get
the cost is exponential.
Well, it's then you'd actually be spending less money by using more net zero supplies to your home with natural electricity or hydrogen than trying to save it.
Absolutely.
That's nice.
If your goal is decarbonisation, you could do no insulation whatsoever and just get a load of solar panels, batteries, and heat pump, and you decarbonise. If you would just, so there's that. But that is not to say that's the case in every scenario. What I'm saying is there's a balance, as you were trying to say, and the world isn't black and white. That's what the solution is.
And no, I would challenge you a little bit there. Well, we can have a long conversation about batteries, perhaps, but the source of the electricity generation for heat pumps is much better from wind because it's seasonally relatively flat, but actually slightly better in the winter than the summer. Whereas if you want to invest in your own home and put a battery in, put solar panels in that feeds electricity to the heat pump, in particular the shoulder seasons, then great, do it. But as an investment decision across the system, because demand for heat, not heat pumps, demand for heat, and supply of electricity from solar are diametrically opposed. They are opposites across the season. Then that is a bad decision to do. You'd end up having to.
I'm something saying,
but the yield
curves overlap. Yeah, I get that. Yeah, I mean, it depends what happens grid side as we, go into feeding back in, etc., which can balance that. If we can help with the peaks and troughs throughout the day with the little spikes of, energy, and also let's remember those solar panels and battery aren't just to feed a heat pump; they're to power the
No,
home. So it's
yeah,
going to power your oven, all that. So they're still worth doing.
yeah,
But yeah, no, I do get what you're saying there. I don't think that was a full, I mean, it's decarbonised at point of use,
yeah.
obviously, and it's reducing demand on the grid, and it helps the grid at night time because you can drink up energy at night time.
Yeah.
Therefore, do you know what I mean? So there's lots of ways to dice up that argument. Um, but yeah, again, this is why I'm kind of still coming away from hybrids. If you're looking at hybrids, you're putting on another 2 or 3 grand on your install of your heat pump. I mean, just get 2 or 3 grand's worth of insulation and get a heat pump on its own. Like, it doesn't
Yeah.
make sense to me at all.
I'd say have the insulation anyway when you want it, but
Yeah.
what it does is it transfers some investment from the energy system to the home.
Mm.
That's the extra capital cost of an appliance in the home, but it can provide so much more savings in the energy system, upstream in the system, helping to give greater utilization. So a lower capacity of generation and a lower storage requirement.
Yeah.
So looking at it as just a home, it looks like a more expensive solution because the actual kit you put in costs more, but it's the benefit you get from savings upstream.
Yeah.
It's a hard story to tell.
Again, like this is why this whole conversation is quite difficult, because you can either look at it from the homeowner perspective or the grid perspective, or there's too many angles. And then when people argue or debate, however you want to term it,
Yeah.
they're talking from different angles, and they might be right. It's the old 6-9 analogy. You've got the two guys looking at the same thing, saying it's a different number. Like, this is why this whole conversation is so difficult, and there's so many different factors and variables.
And the customers, householders, homes, they need to be able to trust those who are trying to develop the options and the solutions, a range of solutions at a regional level, local level, whatever, that this is the right thing to do for them, or the right basket of options for them at a local level. Trust is important.
So we know that. So gas is going to be kept in the things that it's absolutely needed for. So like,
it's going to be kept. What? Sorry?
It's going to be kept for the things it's absolutely needed for, like steel. The things going to need for things it's absolutely not needed for. Like right now, are typical homes. Like, so they could start being moved over to heat pumps. So how, like, as we decarbonize homes and take them off the gas network, what percentage of homes do you think will be left needing that gas supply if money wasn't an issue and we could just pay for every heat pump to be put in? What percentage of homes do you think would be left to go, no, it is going hydrogen that home, if and when there's enough hydrogen after we've fed industry, transport, all the other things that needs kind of supplying? What? Or another way of terming that question, sorry, because I've kind of explained it in a complicated way. What percentage of homes do you think we could heat pump without any backup boiler?
I think we are way too early to try to decide what that would be, but
of course,
there's been some helpful spatial analysis undertaken as to what proportion of gas grid connected homes. So that's not all homes, obviously. What is it, 82%, something?
Yeah, that's about that. Yeah.
What proportion of those are within the kind of easy supply reach of the large scale production areas around industrial clusters, for example?
Yeah.
And that spatial analysis, so I don't believe this went down to actual detailed network pipeline by pipeline level. I mean, that's a next step to be done, and I think it's being done anyway right now. But that showed that about 42% of gas grid connected homes were within the easy supply reach of industrial clusters. So I'd say that's a starting point for the opportunity for the choice of customers to have hydrogen in their home if they want it when it comes.
Yeah, but like we don't know what the price is going to be. So, but we know what the price of heat pumps are. So, like, what percentage of homes do we think can be heat pumped? Because even though
Um,
if we can get hydrogen to them, fine. But
yeah.
if
Well,
they can have a heat pump,
we learn by doing, don't we? And by sticking with Wales, they've done a lot of really good work in trying out different solutions, trying things through funded work through social housing, and they found that they haven't said there's going to be hydrogen heating, but
yeah.
they are keen on the development of the option of hydrogen heating because they've not had total success with deploying heat pumps into all the homes they've tried through all the
Right.
projects they've done to learn.
Yeah, this is the problem, and I've got a big problem with it. There's lots of trials out there going out and saying, "Oh, heat pumps do and don't work there." And you look into these things. It's like the trial. When was the trial? Was it 2017? Was it? The EST did that study and found the average heat pump efficiency was like the copper 2.7 or 2.6 or something like that. But then they found that the main finding was that the breadth of COP, regardless of the house, it was mainly on the installer or SCOP, was so wide.
Yeah.
And actually what it was, and it didn't matter if they're MCS or not, it was just that it came down to how good the installation was. Because people are judging if heat pumps work based on poor installation practices. So, in my opinion, and this is going to sound salesy maybe, but this is my honest opinion. If everyone did our course like the Heat Geek course, sorry, but it's the only one out there. I think the average COP would be so high that this conversation would be completely different. And I think all of these studies that say they do work here and they don't work there would come out with completely different results. Having said that, which study was it that said
this is I'm paraphrasing because it's a long time. I don't know, maybe a year ago I listened to it. This is the energy minister, climate change minister for Wales on a Twitter podcast, live stream podcast with Nesta.
Right.
So go and have a listen of that. I don't think specific projects were talked about, but I've worked very closely with Welsh Government before on a range of different things, and they do a lot of really, really good stuff. And the housing associations are using an annual funding pot to go and try new things, smarter things, different ways, special paint for inside your home to make it more efficient, different heat pumps, hybrids, put in retrofitting gas into retrofitting hydrogen, into like one or two unoccupied housing association homes at the moment to be able to have installers go and learn about how to install a hydrogen boiler, to add different things to the homes, to be able to see what efficiency would be.
But why would we go and spend time on learning how to put in hydrogen boilers into homes if we don't know how much it's going to cost? Like, isn't that a pointless exercise? Shouldn't someone be finding that out like now before we spend money on the hydrogen villages or whatever? Because it's like that is so important. Because across the cost of living crisis, it's so important to know that before we go and chuck money at it. Yeah. Why is no one answering that question that everyone's asking?
Do we know the cost of an energy system being run where everyone's got electrified heat with heat pumps? No, we don't.
No, we don't. But we have a definite broad idea, and we can project on at least we can, and we can say relevant, to inflation, etc. We know what it is today, for example, so we can we've got something to relate it to. With hydrogen, we're literally just saying we're not going to say. We must say something. All the things that I do, all the calculations that I do, say that hydrogen is going to be between 2 and 5 times more expensive than natural gas. And for me, my kind of statement is that heat pumps, on average, are the same running cost as a gas boiler. In reality, I say that to be nice. I think heat pumps are about 5 to 10% cheaper, to be quite honest, if they're put in properly. That's the massive caveat. If they're put in properly with good kit.
So it's not all about what the price per kilowatt hour is of electricity and gas or hydrogen, and that's particularly electricity wise going to be changeable depending upon the time of year and weather conditions and how much of the capacity is being
Uh,
utilized.
and unless we store as excess as hydrogen and then turn it back into electricity.
Then there's the cost of, I don't know, 250 gigawatts or something like that of gas engines waiting there.
Yeah, but that would still be cheaper than converting into hydrogen, then going through a boiler, because you'd need much more hydrogen.
I would disagree. I think
you can't disagree with that because it's physics.
Overall, I think that the total.
I'm glad we found something we could disagree on, because we're going to drill down on that.
The total system cost translates to what an energy bill will be for customers, and that includes the cost of storage, the cost of the capacity of backup generation, the capacity of intermittent generation, and how much that's utilized, and the cost of producing hydrogen, the cost of everything, the cost of upgrading any network, the cost of upgrading a home with technology, with maybe new emitters, maybe new pipe work, whatever. The whole lot. And the evidence I see from like Imperial College and what's come through CCC before is that they're pretty much not far off each other. They're pretty much the same, similar cost.
What, as in hydrogen's going to be the same cost as gas?
So the total system cost of a system that delivers hydrogen for heating and one that delivers heat pumps for heating, which I don't really like, because that's comparing just one extreme with another, by the way.
Well, I think it's important to do, because we need to pick a route.
I
don't think that means, don't get me wrong with saying that means we need the same answer everywhere. There's no panacea. That's literally our motto.
Oh, I'm with you on no panacea, absolutely.
But I think there's 98.5% of homes are going to be fine on heat pumps, or an electrical version, and there's going to be 1 to 1.5% maybe for hydrogen. It's going to be stately homes and stuff, in my opinion. And I'm not saying my opinion's fact.
The CCC's 6 carbon budget balance pathway is, I think, 11% at the moment. So
it's wrong.
Well, I think most people find it uncomfortable to disagree with them, but do disagree. Of course, with them. I disagrey with them on
for a reason.
That's fine.
Yeah.
We've skirted past the network issue, so I think what's quite a helpful thing to look at there is, and if I've failed to answer a question because I've just thought of something, come back to me on it, please.
I know, we keep both doing it. We're both going all over the place.
So network-wise, Cadent and Electricity Northwest did a really good piece of work for Greater Manchester on, I think their target date for net zero is 2038.
Okay.
I do find it quite interesting when local authorities try to outbid themselves, and I'm sure one of them has just announced they're doing it by 2017.
Right. Okay.
I don't know. No, I'm joking. I'm joking.
Okay.
They try to outbid themselves, and some of it's quite obviously politically driven. And then the civil servants think, how the heck are we meant to deal with this? But the piece of work for Greater Manchester was looking at the networks and what they can deliver, and looking at what they can do in a very dynamic system in supply and demand, to deliver what was needed by 2038. And I think, and I don't necessarily think it's always the right thing to do for an off-gas grid home to be a heat pump, but they certainly can be with the right investment and approach to it. If I bought an off-gas grid home and I was going to give it a pretty extensive renovation, I would, I'd be stuck between a ground source heat pump and air to air, depending on how open my rooms were. But either way, this piece of work.
Ground source. There's no space for ground source anymore. The air source. Air source have become the SCOP and air source has come up so high that ground source are now they now compete. Air source are now as efficient as ground source. That's what I'm saying. This is what's changed in the last 20 years.
Well,
taking the thing there.
This sounds really controversial to me.
It's because it's about the information's about a year and a half old. It's not, because most people's opinion is based on this. That's my whole point. It's based on the last 15 years of heat pumps. heat pumps have taken an evolutionary leap in the last 2 or 3 years. Heat
Yeah,
pumps
but
and installers. So again, we're going into I'm going to put that in the parking lot. I'm making little parking lot tickets
yeah,
here.
ground source versus air source. And there was a bit of there was niggles going on like during the Freedom project about ground source versus air source. Not that we're ever going to use a ground source in Freedom, although I'd have loved to have done. But this is quite striking.
Oh, well, we can come back to it so you can finish your point.
Okay.
I'm making a little.
So Greater Manchester. Then all the buildings that were on the gas grid. I think they were all going to stay with a gas connection with hydrogen, and about half of them were going to have 100% hydrogen, roughly. It wasn't just 50-50. There were reasons behind it, and roughly half were on a hybrid between an air source heat pump and a hydrogen boiler.
Yeah.
And I think that was a really helpful collaborative piece of work to do to look at the pathway of investment in networks to deliver decarbonised home heating affordably in that time frame. That should I think point towards Ofgem and their future price controls. And currently they're separated, and distribution networks, gas and electricity, have separate price controls that don't happen at the same time. And I appreciate if they happen at the same time, that'd be quite resource intensive.
Yeah.
But if they happened at least at the same time, then there'd be some helpful comparison of what investments could be undertaken in the different networks. But I think it does point more towards a whole systems RIO. So the regulatory periods for networks are called RIO at the moment, which is revenue equals innovation plus incentives plus outputs. And if they did a whole systems equivalent of RIO, that would be networks working together to work out, well, say for that part of Swindon or that part of Nottingham, we've got major capacity constraints we're not going to be able to resolve by whatever in the electricity system. So maybe that should be prioritised for this first, and so investments in something else like hydrogen for that local area first. But this area, we don't have any constraints. And so
I don't think they should test any hydrogen on anyone until they can give us a right price and how much it's going to cost. I can't get over it. I'm sorry. Because we're taking green. We've got a video on this called "The Great Hydrogen Con." It's called, and
I've seen it. No, I've seen it.
It's clickbaity, But like the whole point for me is we can take green electricity and we can multiply it by 3.5 because that's the real average, Scott. Say 3 if you like, fine. Or we can go and erode that down to about 30% of its net worth by the time we've generated heat at the other end. Like it doesn't. So then we need tons more wind farms, which we're already, and we've got to get this like 1,500 terawatt hours, and we're only at 125. Like there's just too many things saying no for hydrogen for me, and like none of this answers it. Can I just go back to one of the previous points from the parking lot? We said that there's going to be a bit of an issue potentially with supplying powering the grid if we put heat pumps everywhere, because I'm like heat pump at the moment until I'm convinced otherwise. I'm definitely up for being convinced otherwise. So we need 275 terawatt hours of heating for homes in the domestic market. My suggestion is we can, when we've got times of excess, generate hydrogen, turn that hydrogen back into electricity to power heat pumps. If we if we do that, we get like 70% loss or something like that. I think it's 60-70% loss. However, so let's say we end up with 35%. However, when we put that through 350% efficiency or 300% efficiency, we end back up at the original 275 terawatt hours. Does that make sense? So because this is the argument we were saying earlier on about whether it would be better to run it back through a heat pump or send it to a hydrogen boiler, which you said you disagree with. If we then just send it to a hydrogen boiler, we end up with 30% of the power. So how is it better to generate hydrogen and just put it for the grid? I'm not there.
Yeah, so for the grid. So when you look at the like Hydrogen Science Coalition's diagram of hydrogen and heat pumps and the pathway from wind turbines to the home and the efficiency losses and efficiency gains of hydrogen heat pumps, what it's missing is, in the heat pump story, the mega gigawatts of backup capacity that has to be at a cost. The mega gigawatts.
Why does there have to be backup capacity?
Because of the supply demand imbalance.
Yeah, but what I'm saying is we can use hydrogen for the backup capacity.
Oh yeah. This is with hydrogen as a gas backup capacity. So
yeah, but not to run hydrogen, through a sorry, people outside the window.
To have 216 gigawatts of backup hydrogen gas engines, 80 gigawatts of batteries compared to 1.2 gigawatts today, 45 gigawatts of vehicle to grid flexibility, 110 gigawatts of thermal storage.
Yeah,
that all comes at a massive cost to be able to balance supply and demand.
You mean the manufacturing of the actual unit, the creation of the combined gas hydrogen turbine?
The capital investment and the operational investment.
Yeah, but I've included the operational losses in that calculation.
Yeah, well, if I can,
that's all in that video, the hydrogen con video.
If I can point you to Imperial College produced some really good stuff on total system costs and their WeSim total system model.
Yeah, definitely.
This is what they did for Carbon Trust, I think it was.
Okay.
Flexibility in the UK. They looked at well, it might not be worded total system cost, but maybe cost-effective pathways or something like that.
Okay.
And that looks at hydrogen, at heat pumps, and at hybrids. Cool. But interestingly,
when was that study done?
2021, I think it was.
Okay, cool. Do you know what it's called? No pressure. You can send it over to me later.
Well, if you search,
I'll search it.
Carbon Trust there. That looks at those three different pathways. Interestingly, the hybrid pathway looks at screwing down the use of the boiler so hard that you only get something like 10% use out of the boiler, the gas system, and it's chosen or I don't know, decided to use natural gas in that hybrid system, and that there would be a direct air carbon capture to mop up the carbon of that pathway. I'm not decided on the pathway.
Why would there, like even at -7, we're getting a COPS of 2.5. So I don't know why we would turn on a boiler at that point, unless they're talking about running costs to make it So even at running costs, they're going to be the same then. No, it doesn't make sense. I'm not. Do you know what SCOP they used for what SCOPs they modelled with on their? Because this is the thing that people like. This is where studies build on studies. So they'll like, for example, they'll use the EST study of the average SCOP's 2.7. We'll plug that into the thing, but we know that that's not correct. Because units are better, which is why the ground source is now a dead duck a little bit. And B, I mean,
you said that.
I'll come back to that. We'll come back to that. We'll go into detail. We can go into detail. And also training, because those 2.7 SCOP people weren't trained properly. We know we haven't got proper training in this industry. That's why they're being put in craply. Craply is not a word, but you know what I mean.
So the range of stakeholders who fed into this piece of work is extensive and high caliber, I would say. So I wouldn't have expected. I wouldn't have expected their assumptions to be overly in need of challenge. Really,
I would like to be comforted by seeing some good studies, and I'd like to be comforted by speaking to people who really understood the industry. Like, the reason we are where we are in this industry is because the people writing papers are just writing papers, and they're clueless. Sorry, it's the guys on the ground that know much more. They're not respected enough. The guys holding the tools know so much more than the people who are paid millions and millions to write papers. And if those millions were diverted to the people actually doing, not talking about, we'd be in a much better place. I get infuriated by it. All of these.
There's a great deal of benefit to combine the knowledge of
system engineers upstream and system engineers installers downstream to get a better outcome.
You look at the where the money's diverted to, though. It's like 90% to academics to repeat the same papers over and over. May I add? They're not writing different papers. They're all comparing hydrogen, heat pump. They're all doing the same thing over and over in different ways. I went to I actually was invited to do a talk at a thing. I'm not going to say where it was actually, in case this comes across badly, but and mine was very different because I was doing, because we put in heat pumps nationwide, nation's largest hydrogen boiler installer, etc. Everyone else, so there was like 10 other people. They all talked about their recent study they did that year, and they all said the same numbers over and over. Like, it was absolutely infuriating. Like, mine was a breath of fresh air. It was a bit different. Might have been crap compared to those, as I'm not university trained or anything like that. But I don't know. I just feel like there's too much money being put into studies, and
the similar could be said that those who are the system operators of gas networks, who are the experts in balancing supply and demand during the day, are ignored by people writing reports on just.
I tell you why I totally agree, but it's going to be for a very different reason. The national grid say that we can electrify the national grid. They say it's not a problem. Just get on using time of use tariffs and everything else we've got available. Local storage, battery storage, car storage. Using all of that, the part they say it's totally doable. So I mean, what you saying it's difficult goes against literally the people that do the job.
Well, there's two national grids, by the way. There's national grid, and they have gas transmission and electricity transmission, and now they've bought Western Power Distribution as well. So then distribution.
I'll tell you exactly who said it. It's the main guy in charge of.
They also have the USA National Grid, and the USA National Grid strategy going forward is heat pumps and hydrogen for hybrids in the US.
Right. Okay.
It's very interesting. Yeah. But you'll find National Grid say that hydrogen's got a significant role in the future of heating from their gas side, and then from the electricity side, you get the what's it called, the FES, future energy scenarios.
Yep.
Yeah.
So I'm just finding this guy's name while
but that National Grid have recently, as far as electricity concerned, come into the distribution end. But those things may have been said from a electricity control or electricity transmission perspective.
Correct.
But still, there's a massive amount of new cabling needed to bring in electricity supplies for the future.
Yep. And then there's going to be a lot of repiping needed in people's houses if they want hydrogen as well. So I think it kind of, and I think that's needed anyway. Do you know why we're going to need that anyway? Because we're going to go to electric cars. You agree with that, right?
I think probably largely. I'm very interested.
If we're going to electric cars, I mean, the amount of electricity needed for heating is like what, 2 kilowatts roughly. You might need 3 kilowatts in December, maybe. Average household is 8 kilowatts, right? So, but for a car charger, it's 7 kilowatts. So it's going to need upgrading for the 7 kilowatts of car chargers anyway, probably. Yeah. And yeah, having said that, it's not going to be upgrading loads because of time of use tariffs. Industry is not going to operate at peak times. Industry is going to operate at night, during the lulls, midday. So that evens out the grid. Like, there's lots of tools that are available.
Well, lots of it. Industry that receives a gas supply today is typically flat 24/7. So actually modeling industry in the future, it doesn't really change all that much.
Of course it's flat 24/7 because they've never had time to use tariff before. But when it's economically
so a gas network who I know runs, or at least used to, I assume they still do run auctions on like interruptible auctions, flexibility auctions, and you can choose as an industry how long you're willing to be off supply for, or how much you're willing to reduce your supply down to. So anything between 0 and 100%. for however long, 1 minute, 1 hour, 1 day, 1 week, and how much you want to be compensated for your conditions that you've put. And they're all invited to submit their bid, and none of them are interested in bidding because utilization of their assets constantly and meeting their order books is more important than losing supply. In fact, losing supply can destroy their assets. And so they won't be able to carry on anymore. Like steel works, for example, they can't go coal.
Yeah, I mean, there's so many challenges, isn't there? Sorry, I'm still trying to find that bloody guy's name, and I can't find it. I'll come back to that. I'm just going to go back to the ground source versus air source, because that seems to have blown your mind.
Yeah.
Have you seen?
I feel like this is really going to upset some people I know working in ground source heat pumps.
I mean, have you seen? I mean, what SCOP? Because this is consumer. What SCOPs would you expect from a ground source heat pump?
5 to 6.
Yeah, up to five to 6. Yeah, exactly. So, but from 3, right? From 3 or from 2.5 historically up to 6. 6 absolute max. So with the, for example, the one that we installed, Valent Aerotherm Plus, these are already achieving 5. They're not hitting 6. But even if you get to 5.4, that little bit extra at the end does not pay for your boreholes or anything, even at current or double the electricity price.
Is that when the shared loop
isn't viable?
Is that when the shared loop argument comes in? Yeah.
Shared loop argument when there's a good unit. At the moment, I'm not going to name names, but the heat pumps that connect to shared loops aren't the best.
Okay.
Is all I'm going to say.
Yeah, okay. I've
shared loop is not what shared loop isn't what I was referring to. I was just talking about, so boreholes. It paid off before, and it paid back because of so 2 reasons. RHI, it paid double, right? So it was a no-brainer. Get RHI, you would always go ground source if you had the upfront capital. So that's done. Now you get £1,000, so it's £5,000 for air source, £6,000 for ground source. So you're getting £1,000 back. It's going to be 15 grand more for the boreholes probably, although they should come down in price a little bit because there's a load of borehole drillers walking around doing nothing now. So for that little bit of SCOP you're saving that you can easily get with a heat pump, like an air source heat pump, it's not. The only reason you get a ground source now isn't fiscally. It's it's just because you don't want to see a box outside your house. That's the only reason now.
Wow, interesting.
Well, I mean, you can say interesting. We've done probably our 100th install at the end of last year. That's last year's. That's all the heat geeks nationwide. Go and ask them what SCOPs they're getting. They're getting ground source heat pump SCOPs. Like there's been an evolutionary leap with the latest controls and refrigerants that are getting way better efficiencies. Having said that, ground source is a bit behind because there's not very many inverter driven ground source. A lot of them are just on off, so non-modulating. There's not that many. I think there's like 1 or maybe 2 R290 ground sources. So when they come up and maybe meet the latest iteration of air source, maybe they'll be slightly better. But without the RHI and only marginal gain in efficiency, I can't see a fiscal thing. And we're reaching the end of the theoretical Carnot SCOP anyway, so it has to cap somewhere.
Yeah.
I think it's dead. I think it's dead, mate. Like it's a totally specialist thing.
Why is there a fly alive in January? Because I know of various new homes developments, and I know one that's got ground source.
Yeah.
And I think when something like when you add up all the cost of the install of the ground source and the additional kit, and I think it needed I think one in particular might have needed a new substation as well.
Right.
Without the substation costs, I think it was adding something like £40,000 per home.
Yeah.
Which was all funded not by the purchasers of the homes. It was all a funded project. I can't. That particular. I can't imagine that happening in a commercial environment. But
Mm.
And that's it. That's new.
Have you seen our video on our heat pump in our office in Farnborough?
No.
So our office in Farnborough is a 1957 building. 1957, I think it was built. No cavity insulation, 100 mil of loft insulation. So you really want 270, 300, as you're aware. It's got double glazing, but you can literally wobble it in and out of the frames. And 6, it turns out, of the windows are blown, so the gas has been lost from the middle.
Yeah.
The radiators, there's not a radiator in the hallway, there's not a radiator in every room at all. The radiators they're not triples, they're type 22s. Guess what our scope is?
Well,
I'll tell you. It's a bit of a silly, it's hard. So
someone's on hand to make sure it performs damn well, and we've got a good team.
You don't have to touch it. Like you set the weather compensation, no room influence, and we just leave it. It's currently at 4.12, but we're in January, so we've got the other spring to bring it back up to. It's going to end up about 4.6 with normal radiators and no insulation. If we then go back and insulate that, which we're going to do, if we go back and insulate that and put in an extra couple of radiators in the rooms that aren't heated, we're going to be over 5, and that's just a normal 1950s, 60s building. This is the reason why ground source, meh, and hydrogen, and I was there with hydrogen. These things are performing so much better than I even ever possibly. I am not a seasoned heat pumper. The only thing I'm good at really is hydronics, and I absolutely love hydronics and physics and how all of that works. I really like that. It just so happens that that's the most important thing to do for a heat pump. So actually, I'm really good at heat pumping, I think. So when I started doing heat pumps only a couple of years ago, I was still skeptical. I was like, no, we need a mix, no panacea, like really feeds into our thing. Since we've installed in the last year, or in the last 7 months, we've installed 100 heat pumps. I am like, there is only one way to do this now. These things are performing so well. And I'll add to that, if I go back a year, 2 years before, the upgrade, like how they're performing a year or 2 years before to how they're performing now, as in the technology itself and the upskilling of the engineers, that shows a trajectory. We can't get heat boilers any more efficient. Like the energy just can't be found from anywhere. But heat pumps are still on an upward trend. I do think we're going to be curving off. But I think they've got a little bit further to go. And because of that, and because I've seen how well they perform, I can't get out of my head. I just can't see hydrogen being a thing. I think gas in homes is dead as a general, except for maybe the 2%. And this is my opinion. I'm not saying this is fact. And I totally respect anyone having different opinions to me. I'm often proved wrong. And if I'm wrong, I shout on the channel. It doesn't bother me. I just like being part of the mix. I really enjoy it. But what happens to IGEM if we do start, decommissioning the national grid?
Yeah. So, what rarely gets talked about is the cost of decommissioning a gas grid, and that is certainly not insignificant.
Good point. Yeah,
certainly not insignificant. I mean, as far as the network's concerned, if we have a range of homes that aren't connected because they have a heat pump solution, and some areas are connected because their region's got a particular challenge on electrification or particular advantage on hydrogen or something like that. We might have different areas.
Yeah.
But
did you have any numbers for
how much it costs?
Yeah.
I won't say a number now because it's so long ago.
They're not hard numbers. Yeah. Okay.
But they've been estimated by say academics in modelling, and I'd probably say they've been underestimated. Yeah. But I don't think you're going to be in a position where all the gas grid is going to be decommissioned anyway.
No. This is hypothetically talking.
Yeah. So the high pressure system is a massive undervalued storage asset. There's about, I think it's roughly about 1 terawatt hour of storage capacity per day you can fill and release.
I'm there with that. That's why I keep saying I really like the idea of storing excess electricity as hydrogen and then turning it back into electricity for heat pumps. I think that makes total sense.
And then
unless battery technology improves.
and then but when we look at the possibility of different energy demand sectors and what they might do in the future, quite often that's looked at on a silo perspective. So what about this particular type of industry, this type of industry?
Yes.
Vehicles, homes, commercial buildings, stuff like that.
Yeah.
And well, it's definitely needed for this, it's definitely not needed for this, and there's a range in between. What that misses is the deployment of hydrogen with co-benefits across all the range of demand sectors. So if you've got hydrogen for industry with a hydrogen grid connecting a range of different industries, then you've got that base infrastructure there to connect into. You're not building any new infrastructure just for that. You're just taking advantage of what's there. Take for example, I'll not say what company it is because it was said in the House of Commons, and so I don't want to upset anybody. But a company where you'll know the brand and it's probably in your cupboard. Let's say. In London, on the Thames, not too far out of the centre of London, they've looked at what their opportunity is to decarbonise, and they could either have natural gas with carbon capture and a carbon pipeline that needs to come to take it away, or they have a hydrogen pipeline. And they would have to double the size of their massive factory to have carbon capture and carbon exit from the site to a pipeline, which obviously they don't have.
Makes sense. They
need a hydrogen pipeline, and this is not just one. This is many companies wanting to say, give me a hydrogen pipeline.
Yes.
And then the hydrogen pipeline can be used for others. And it's there's industry within residential areas as well, and so
yes, that makes sense. I'm with you. Yeah, it's neat. Like we need hydrogen. We are definitely going to need hydrogen in all the other things that I've mentioned, aviation. Or I say definitely. I don't know much about them, but that makes sense to me. And I think there's tons I haven't thought of, and tons I don't know about either. Like I'm an amateur in this. To be quite honest,
I need to learn more and more about the installer side. I actually went into I did an installer course to install. It was only short, mind you. To install solar thermal, but don't let me because I'll destroy your roof.
Well, you should come on the Heat Geek course. That'll be interesting.
Maybe I will. I'll bear that in mind. I will bear that in mind.
Yeah. Well, you're more than welcome. We've probably come up to about our time now. I would say, like, just in summary, as we were saying just then, like, I do definitely think hydrogen has a place. I think storage for sure. I don't think there's any battery. Maybe there is battery technologies out there that are comparable, but I'm not aware of them yet. I think there's definitely industry, steel making, etc. I don't know if that's going to be local or if that's going to be gridified or whatever. But so I do think there's something there. I'm still not there for home. I haven't swung back for homes, except for like the stately homes or like the 2%, or maybe even 1%. I don't know. I'm not too sure how's the broken up. But I still think, in my mind, I'm pretty set, but I still think there's room for debate, and the conversation isn't finished. I would also add, though, that I think heat pumps are winning in the general discussion.
Well, hydrogen was those who are lobbyists on full electrification. Were very welcoming not too long ago of test hydrogen at a scale, test it in an area, things like that.
Right.
But now it's in a strategy to happen.
Now they don't want it.
It's not all that popular. But everything needs testing to develop. How easy is it to convert a local network sector by sector?
If I totally agree. If we're going to have a serious discussion about this, we do have to test. I think the people we're testing on should be aware of all the things, all the risks, etc. But I think I don't think we shouldn't not test something just because we don't think it's a good idea. If we're going to have a real discussion, this is going to go on for centuries, this decision. So the more information we get at this point, the better. Like we shouldn't not test something because we don't think it's a very good idea in general. Forget that. Let's do experiments, because even though it's a few billion or whatever, it's nothing in the scheme of the next 100 years multiplied over the whole country. So I am there for kind of experimentation and testing, provided it's proved that, roughly theoretically first, and the participants are willing to do it, aka the Whitby issue, which we can't go into probably. Is that still a court case? Is that still going on, or?
Hey, I'm not part of the project team, so I can't really comment on it.
They keep messaging me and wanting me to get involved. I don't want to get involved either. So. Right. Have you got any closing sort of statements before we?
Let me just pull up this essay I've written. No. This is good. I've always wanted to have productive conversation with various different views, with various different expertise.
Yeah.
Because without it, I don't think we'd make much progress. That's good. And I think there's a lot of wasted effort. I think wasted energy, wasted effort, wasted energy on maybe attacking, maybe say that's not a good thing, don't do it, and spending a lot of time doing that when that wonderful knowledge that there is in something that is good could be better spent doing something positive to get things deployed and installed to bring emissions down, to bring cumulative emissions down, to get to net zero quicker, and to mean that we have fewer climate change impacts to deal with, and to build adaptations that all comes with cost as well. So
what a fantastic note to finish on. That's I wholly agree with that, and that should extend to online as well. Like people aren't, debate is good. Ollie, I say Ollie rather than Oliver, right? Ollie?
Well, it depends if you're telling me off, Ollie.
Ollie, then. It was really pleasure meeting you the other night at the awards as well.
Congratulations on that award and the one you had after that as well.
Yeah, that's it. Yeah, I have to get Ralph now. I've got to.
Yeah.
We'll stay in touch, and maybe as things develop, we'll do an update to this podcast.
Yeah, happy to. Yeah.
Awesome. Really, really, really glad you came on. Thanks, Ollie.
Thanks, Adam. Cheers. Bye now.
Cheers. Bye.